Hello students. Next, let us look at the next function that is important, which is the exponential function. The exponential function is e raised to power minus at u of t with a being greater than or equal to 0. That means basically a is having only positive values. Okay, a is having only positive values. So if we are going to draw that, if you just take your calculator and calculate e raised to power, let's say minus 0.25, e raised to power minus zero point 0.5, e raised to power minus 1, e raised to power minus 1.5. You keep on taking these values. Okay, before that you also take e raised to power 0. Okay, e raised to power 0. So e raised to power 0 will be 1. That is what is the value we are having here, 1. And then this value will basically go down. This one will go down. Each of these values will be less than 1, and slowly you will see that the value basically keeps on going down, and it never becomes 0. It becomes 0 only at e raised to power minus infinity. So you might be looking at the t here. See, t is always positive value only because you have already written u of t. Okay. Now, generally, if I am not keeping this u of t, the signal will look something like this. It will look something like this. Okay. It will look f of t. It will look something like this. But since we are taking u of t means we will be only taking the values from 0 to infinity. So basically this much portion will basically be not there, and that is why we are having these values as 0 here. Okay, and then from this value we are having, so this is always going to be 1, and then this value slowly goes down. So that is basically what is our exponential function, and exponential functions are extensively used in electronics and communication. For various different subjects you will come across this function e raised to power minus at. There is another e raised to power minus j omega t that we will see later. Okay, right now e raised to power minus at. So this function, if we are going to see, we will find out that we can take the Laplace. Okay, so if we are going to take the Laplace of e raised to power minus at u of t, then we know the formula. It is 0 minus to infinity f of t, which in our case is e raised to power minus at u of t, e raised to power minus st dt. Okay, now since u of t is 1 for 0 to infinity, I can write this equation as 0 minus infinity e raised to power. Now see, you are having e raised to power, suppose you are having e raised to power minus x into e raised to power minus y. You can write this as e raised to power, okay, let's take the value as plus x and plus y. Then you can write this as e raised to power x plus y. So whatever is having multiplication, we basically write e raised to power x plus y plus, because this is into, that is multiplication. If it is e raised to power x divided by e raised to power y, then we will write it as e raised to power x minus y. Okay, so here you are having e raised to power minus at into e raised to power minus st. So I can take minus common outside. T is also there, that I can take out common. So I will write s plus a t. Okay, why? Because e raised to power minus at plus minus of e raised to power, minus of, plus minus of st. Okay, that basically e raised to power minus, I can take out common, so it becomes at plus st, from which I can take t commonly outside, so it becomes e raised to power minus s plus a t commonly outside. That is what I have straight away written here into dt. Okay, so rest let me straight away, I will Okay, so now I am having this one, and we know that any exponential function, if we are going to integrate it with respect to time here, we will have Laplace of e raised to power minus at u of t is, so now what is the integration value? The integration is, we know that e raised to power minus x dx, if I am going to integrate it, I will get 1 by minus x, okay, or I can write it as minus 1 by x e raised to power minus x, isn't it? So that same logic we will apply for this one, and we will write it as minus 1 divided by s plus a, okay, s plus a into e raised to power minus of s plus a t with limit 0 minus to infinity. So instead of t, if I am going to put, so I will write this as minus 1 by s plus a and e raised to power minus infinity minus of e raised to power minus 0. Minus 0 is having only one value, which is 0, so no need of writing minus 0. So this will become minus 1 by s plus a, and e raised to power minus infinity is 0, minus e raised to power 0 is 1, that minus and minus will cancel and we will get 1 by s plus a. Okay, so this is again Laplace of e raised to power minus at u of t. So therefore we can say that Laplace of e raised to power minus at u of t will be 1 by s plus a. Okay, 1 by s plus a. Or I can write e raised to power minus at u of t is Laplace transform. If you would take, you will get 1 by s plus a. So that I will put totally in a box. Okay, I should have used a thinner one. Okay. Okay, so this important result I have to write it in the other page. So let me take that. Let me take the color. Yeah. So the fifth result is e raised to power minus at. I'm not going to write u of t now. I will get the result as 1 by s plus a. Okay, so this is another important result that we have got. Now based on this we can build up many other results we can basically get, that we will get by studying basically what are the different properties that we are having. Okay, right now according to your syllabus they have not mentioned, okay, they have not mentioned if you need to study the proof of the properties. So let me define first. Okay, so let me see if I have completed all the basic functions. Yes, I have completed. So next I will go into another topic. Okay, so we will stop here and we will go for next the properties of Laplace transform.